Dun, 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 dun. Hello, welcome back to another Prenarculus production. Today we are going to be discussing everyone's favorite topic, partial fraction decomposition. Today we are up to type 4, repeated quadratic factors. Okay, type 4. Now, to be honest with you, repeated quadratic factors are really a combination of type 2 and type 3. If you understand how to work with type 2 and you understand how to work with type 3, then you understand how to work with type 4. So this should be pretty easy. So let's set one up. We'll set one up that's pretty complicated right off the bat. Let's try x squared, x minus 1 cubed, x squared plus 2, x squared plus 4 squared. All right, we'll set that up. We don't care what the numerator is. We're just going to set it up. So the x squared, it'll be an x and an x squared. X minus 1 cubed is an x minus 1. An x minus 1 squared. And then we have an x minus 1 cubed. And then we have an x squared plus 2, which can't be factored. And we have an x squared plus 4. And we're going to need an x squared plus 4 squared, just like in type 2, where if you had an x squared, you needed an x and an x squared. If you had an x minus 1 cubed, you needed to count for all three, an x minus 1, an x minus 1 squared, and an x minus 1 cubed. This is the same concept here at the end. All right, and now let's write what goes on top. On top of the x goes a. This is a linear factor. B. This is a linear factor. C. That's a linear factor. D. This is a linear factor. E. This is a quadratic factor. Fx plus g. This is, oops, never mind, that doesn't belong there. This is a quadratic factor, hx plus I. And this is a quadratic factor, jx plus k. And that's it, you've set it up. Okay, now that would be extremely complicated to actually go and work out. You know, we're not going to work anything out that crazy, but you can certainly set one up like that. Okay, it's not very complicated to set up. All right. All right, so we're going to try just one example on partial fraction decomposition here. We're going to try 6x cubed plus 16x over x squared plus 3 quantity squared. Okay, so we're going to need an x squared plus 3 and an x squared plus 3 squared. Okay, this is like type 2, but with quadratic factors. So on top of this is quadratic, so I need ax plus b. And this is also quadratic, right? This factor is quadratic, cx plus d. All right, I'd put those in parentheses. That'll help you as you go. So now, same old deal. You're going to try to combine them. 6x cubed plus 16x equals, on the right, you're going to have ax plus b, and then an x squared plus 3, right? This one needs one of them. And the second term doesn't need any x squared plus 3. It's already got 2, which is the common denominator. Okay. All right. Now, this is a perfect example of when you should equate the coefficients. No matter what value you pick for x, you're never going to get 3 of these a, b, and c, and d to cancel out. So I would just FOIL it, and then we'll set it, equate it, and we should be done pretty quick. So this is ax cubed plus 3ax plus bx squared plus 3b. Plus cx plus d. There's nothing to even FOIL over there. Okay, so now let's put these guys here together. So we have an ax cubed, but that's the only one. And then we have a bx squared, but that's the only one of those. We have a 3ax and a cx. And then we have a 3b and a d. All right. So let me just erase this here real quick. Rid of that, I don't need it. And rid of this one here too. And let's go, and we'll come up back up here again. So we have 6x cubed plus 16x equals ax cubed. There's nothing to factor out there. Bx squared, nothing to factor out there. We have a 3a plus c. I can factor x out. And then we have a 3b plus d. All right, let's see what we got. So ax cubed is equal to 6x cubed. So that means a must be 6. A equals 6. And then we have a bx squared, but there are no x squareds on the left. So that means b must be 0. We have a 3a plus c is equal to 16. And then we have a 3b plus d, but there's no number by itself over here on the left. So that must be 0 also. Okay, so now we're just about there. Time to solve it real quick. We already got a and b. If I take a equals 6 and put it in this equation, I get 3 times 6 plus c equals 16. So c must be -2. And if I take b equals 0 and put it in this equation, I get 3 times 0 plus d equals 0. So d must be 0. So there are my 4 numbers. I have them all. I'm ready to write an answer. So let's write it. We'll write it over here. A is 6, so we have 6x. B is 0, so I don't need that, over the x squared plus 3. C is -2, so I can actually write minus 2x. D is 0 over x squared plus 3 squared. And I'm all done. Here's my answer. Okay. The one thing I will say, be careful when you put a minus in front of the entire fraction. Remember, this minus sign belongs to everything that's in the numerator of that fraction. So if you did have another number that were hanging out after the x, remember that negative sign would also belong to that number. So just be careful if you decide to put the negative in the front. The other way you could do it is write plus and put the negative up there with the 2x. So that you know the 2 is the thing that's negative, okay? It's just the 2 that's negative there, all right? Especially if you have another number that's hanging off of there. Okay, that's pretty much it. You guys have the basic idea. You understand how to do it. That's what you do if you have quadratic factors that are repeated, all right? The same thing as you do for type 2. Okay? All right, thanks for clicking.